Welcome to module 34 of object oriented analysis and design. We have been discussing about activity diagrams in UML. In the last two modules, we have talked about several of the features of activity diagrams, including the activity themselves, the partitions, edges, particularly object flow edges, and then in depth about control nodes and what role the control nodes play, and we have seen some examples. In this module, we will continue further, and we will specifically take a look into objects and actions, and then we will take a brief look into the leaf management system in terms of the activity diagram. So, this is one diagram you can recapitulate on in terms of what we have studied earlier. Now, the next concept that we have in terms of activity diagrams here are objects. The object is an abstract activity node that is used to define object flow in an activity. See, the way you can conceptualize, if we let me just go one step back in terms of the conceptual model of activities and their diagrams. Is suppose there are two activities here and there is an edge here. Now, there could be, let us say there is there is another activity here having an edge here, there is a decision here, there is a decision here giving you different activities on this. Now, as the this is a representation of the flow. Now, how do you really understand the dynamics of the flow? How do you really understand that how the flow is going? So, the way you conceptualize is you think about certain abstract objects. These are typically called tokens that move from one activity to the other. So, initially when if we represent, we have the initial starting node, the token is here. Then this activity happens, say activity A1, then the token has reached at this point. When it reaches this point, the token gets transferred through the edge and activity A2 starts. Once this is done, the token comes here. So, it is as if the actual dynamics is as if you are tracing through tokens, then you have A3. So, when does an activity start? When all its input tokens have been received. These are simple flow. So, they have only one token. So, as soon as that token comes, this activity happens, and once it completes, the token goes to the output. So, when we have a decision node, naturally after there is one token. So, after the decision node, either the token goes here or the token can go here. It cannot go at both. So, if this is say yes, this is no, and if yes is taken, then this token comes, this token is not there. Since this token has come, the activity A4 will get fired, but activity A5 cannot get fired. That is a basic concept of activity flows in general. So, you can understand that very well in terms of a fork situation, that you have one flow coming. Let me draw it clearly. So, one flow coming here as fork, and you have two flows going out. So, what happens is in terms of this, you had some activity here, you have some activity here as well as some activity here. Now, when this activity A1 has got completed, naturally a token is placed on the output edge that goes to the fork. What the fork does, fork basically duplicates this token on both the output nodes, so that both these activities have a token in the input and they will fire, they will start working. Similarly, when we have a merge, the reverse thing happen. I have a merge. So, I have one control coming in here, one control coming in here, one control going out. There is an activity here, there is an activity say say A5, A6, just arbitrary names, and another activity A7 here. So, in merge what happens is whenever this activity A5 say will get over, it will place a token on this, but merge will not transfer that token here, it will wait for the other token also to come. So, the merge node basically waits for all tokens to come, merges them together, places a token here, and only then this will go on. So, this is the same logic that I have said, but the only difference I am asking you to conceptualize, if you think of a token traveling along the edges of the activity diagram with the further assumption that if I have an activity, then naturally it may have multiple edges coming in and the activity will fire. So, if multiple edges have to come in, you either have a merge node or a kind of a join node to represent that, but only when the token is available on all of them will this activity fire, and once it fires it will place the token on the output. If you think about this, then that becomes much easier to understand. So, whenever we are working with the activity diagrams and two activities A1, A2, and we put an edge between them, we do not mark these tokens, this is implicit. This is the basic behavior. So, that A1 when it will complete, it will generate a token that goes through the edge, and A2 has a token and starts working, and when A2 gets over, the token comes to this. Now, specifically what objects, the role that objects play is, if at places you want that beyond this generic behavior of tokens to manage the flow, if you want some more packaged information to go along with that, you put it in terms of an object. So, it is the same token, but it is this here the token is just not an anonymous one without which is just to control the flow, but it will also carry some information, and you could put the object in variety of different shapes and sizes and different purposes to satisfy different requirements. So, it is best to just have a quick look into those. For example, we have already seen this. So, here if you just think in terms of the simple model, it is an edge from fill order to review order, which will carry a token. Now, we have refined it saying that I have an order object here. So, fill order, which when it generates a token, it actually generates a qualified order object, and that order object goes in here. So, on the edge you see the order happening in this. So, basically these objects will always happen on the edges, because they are basically refinements of the token that has to go through those edges. So, another concept is a pin object, where you show that well, this is a input pin, this is an output pin. So, this shows that when the token arrives to add to shopping cart, you are showing that it is just not an anonymous token, you expect the token in terms of an object. So, it should have other properties also, and you are specifying what object you expect here, that is the item object. Here it says output pin is a out pin token. So, when the create invoice completes, the token is to be placed here. You say that token is not a simple one, that is a object, and that object is identified as an invoice. So, wherever this goes, it will get that object along with that token. So, that is a you can attach the objects to the edges, or you can attach them to the pins. So, if I connect them end to end, so then this will look something like this. So, there is an object here, the object here, and so on. So, this is how the pin objects will work. They look like very similar semantics, because I could instead of doing this, I could have just done an O1 object and could have sent that to the next activity. The reason you bind it to the pin, because you may have different kinds of flows. For example, if you have the same one object generated which goes to multiple of the different activities, then it is easier to show them in terms of pin. Or if you have that different activities can generate an object of the same type which you expect at the input of an activity, then it is easier to show it as a pin. Also, pin provides for certain transformational objects in the process. We will show an example. There are cases of what is known as a data store. Often you will need a data store to maintain the collection of objects, and when you talk about the data store, so data store is again shown in terms of a keyword. So there could be several data stores which you can relate, would later on become possibly tables, or in some cases databases in your central database system. So this data store, so we are saying that the patient admission, this activity ends, the token is generated, it is a outbound object patient, and that's delivered to this object data store. So here kind of you do not have another activity following it. So this is kind of an object which just works as a repository. So objects could be used for such purposes as well. So with that you can have a variety of these. This is an activity here which sends an object which on completion sends a token to the data store, which is a customer database. So making a cell that basically says that you have updated the customer database, and then from this the activity, next activity is ship item, which means that based on this update the shipping of the item will happen, and the outcome, the transformational outcome in this is send and welcome packet. So what you are saying that when this object goes to the edge, then you send an outcome welcome packet based on certain selection criterion. So objects are very objects as qualifiers of the edges are an important concept in activities and can be used in such multiple ways. This is another example of distributing a car, another activity. So you assemble a car, this is an activity. On your out pin you have a car because you have assembled it, that goes to the central buffer. So that's kind of the garage where the assembled cars exist, and from there you could either sell or you refresh the company cards. These are the different activities that can happen. So this basically is a multi-way activity that is happening, and each one of them get a car from this store. So here you can see that this is being a central buffer. This is different from if I had just said that from here to here I have a car. The difference being that if I had just shown an activity assemble car and sell car connected with an edge car, so that you assemble the car and sell car, that would mean that you assemble the car and that particular car you go send for selling, or you assemble the car and that particular car you send for the refresh company, which is not the case. So your central buffer gives you a different semantics where you assemble car and accumulate them here, which is some separate process, and here you have from that central repository you pick up cards and sell them or refresh them and so on. So this is how you can objects can be used to add more semantics into the activity diagram. Then you have other than objects you have actions. Actions, they are also named elements. So the action is the process order action. So what action mean is basically it means there could be these are activities or algorithms at a certain level, but you may want to actually have a more direct algorithmic or programmatic representation of that. So you could also define actions which are expressed in certain programming language. So actions not necessarily are generic in nature. You could have actions in an UML activity diagram which is specific to the UML tool you are using, so that you can give more and more details. For example, you could have a C code attached as an action describing that how it will be realized and so on. So actions give further details and low level details in terms of that. And certainly since you want to model the overall activity, so actions could have local precondition and local postcondition, which say that if this action has to happen, then what are the conditions have to be satisfied for this action to take place. That is the precondition, and what will happen after that. So if the precondition here of processing order is all information was provided and the order has been prepaid, the payment has been made, only then the order can be processed. So that is the precondition to this, and the postcondition certainly is the order is complete and verified. So actions take place in this way. So this is another just showing dispensing of a drink. So the precondition, the action of dispensing drink has a precondition. that whatever the user or the customer has selected, that is drink is low calorie say, and the post condition has to make sure that the dispense drink is low calorie. You can see pins here, the input and output pin here. The input pin here gives you the name of the drink, so that the dispense drink activity can actually pick up that drink. So, the output pin gives you another object, which is the drink object itself. This is another example of processing order. So, you receive your order request and you send it for approval of payment. You are showing that order object in the middle, which is the object node, and then it goes to the submit order in this activity. You can see this notation of sub activity here. So, approved payment is another detailed one, which takes the order, calculates the total, authorizes the credit card, updates the order status, and finally updates the whole thing in the order itself. So, if we look into this flow, we can see that in the same flow we can look at the object in multiple different ways. This is the first one that we saw, that they receive order request and send it for approval of payment. You have an order object here. We can show the similar information. This is just I am just showing different variants of the same diagram, but with certain subtle changes in the semantics. So, this I can also show in terms of a pin. This is the output pin of receive order request, which actually has generated an order on the output pin, and approve payment in the input pin gets this order on the input pin, and rest is same. Once we change from this representation to this representation, then I can make further changes here. I say that okay, what the approved payment needs to know, really not the order. What it needs to know is the amount of money that needs to be collected. So, when the output pin object could be an order, the input pin object is actually a cost that I am interested in. And so, I can have different kinds of objects at the two ends of the activity edge if I use pin, and I can bind some transformational algorithm for converting one kind of object into another kind of object. This is represented in terms of the transformation keyword, and which here it is simply doing a selection, which is taking the order object, is just taking out the cost component of it. So, it is ordered dot cost, which gives in here. There could be several detailed algorithm, there could be an action involved here, and then you proceed with this whole thing. And at a different level, I can also represent this in terms of this request that I receive payment, the object order object goes to the approved payment, but I am not getting into these details. All that I know that in this object is in a state which is in a pending, because this order is gone for approval. So, this order is an order object, but it is a pending status. Whereas, once the approval has been done, in earlier cases, if you look into these cases, we didn't show any object flowing. It was a default token, but here we show that as if an object is, this order object is flowing from the approved payment to the submit order, the same activities. Only thing that has changed is the status or the state of this order object. So, this is a modeling which is based on the state change information. Later on, when we will talk about the state charts, we will see how different such state information of objects could be combined in different places in UML. So, here I just wanted to show you the power of finally modeling the activities, not only in terms of control flow, which is what we have been doing in the last two modules in terms of activities, partitions and edges, and particularly the control flow diagrams. But here what I illustrate is, on top of this, you can actually make a very strong object flow on the activity diagram, and the tokens that move can carry whole objects with them, defining a complete semantics for the diagram. So, that was a basic overview of the activity diagram. So, if we look at LMS, our running example, then we need to identify activities and the partitions, the control nodes, the object nodes, actions for activities, and derive the activity diagram. Of course, what I show you here is a very elementary form of the activity diagram. I will expect you to work this out at home. So, this is just to show you the outline. So, the different activities that we have here would clearly get in case of LMS, they will clearly be identified from the use cases. So, these are the different use cases that we can say will become major activities in the activity diagram. Managing leave in multiple ways: request, approve, revoke, cancel, avail, export, and so on. So, that is simple based on the use case diagram that we have made. In terms of partitions and swim lanes, at least 2 swim lanes we can immediately think of based on the 2 major agents that we have, that is the employee, because there will be activities that the employee has to do, and there will be activities on the leave abstraction that needs to get performed. So, if you draw it on the swim lanes, then we can say that, well, we start here, and when we start, then it is possible that different employees will take different actions, different activities of requesting leave or approving leave or availing leave and so on. They all start with a fork, because they can start concurrently anywhere, and then it goes on with the different activities. And if you request for leave, it crosses over to the leave swim lane, and depending on whether it is valid or not valid, you have different decisions and outcomes of rejected leave or leave entry. So, this is a central buffer store object, where if it is valid, then the leave is entered and stored. Then avail leave, then it will be deducted. Certainly, there will have to be further, if you cancel leave, there will have to be further activities that will come in. If you approve, then you will need a decision to check if the leave is indeed requested. Only then you can go for approval. If it is not, then it is not approved. If it is requested, then you need to check if the person trying to approve the leave is actually the reporting manager. So, based on that, the leave can be approved, or otherwise the leave will be. Of course, there are further and further details, and what is significantly shown missing in this diagram is we just have the fork, but we do not have the join. That is, finally, it does not combine into some common place. So, you will have to figure out how to do those and complete it in terms of a complete activity diagram of LMS. When we have at the end, we will, when we provide you the UML solution for LMS, we will give you a more detailed diagram, but I will expect that meanwhile you work on this and try to build up the activity diagrams for LMS as well as the AMS and maybe some of the other systems that interest you. To summarize, we have discussed about specifically about objects and actions in the activity diagrams, and overall this concludes the 3 modules through which we have exposed you to different aspects of the activity diagram, how to model in them, how to use that, and we have taken up several examples to illustrate the different features and the use of the activity diagram, and have given a brief over the activity diagram of the leave management system.